Yes, okay. So the title of my presentation is Prioritizing and Implementing Clean Water Projects on State Lands. I am the watershed forester for the Department of Forest, Parks, and Recreation, which means I administer the AMP program, the heavy cut program, our two regulatory programs within FPR, as well as doing many other projects on private land and state lands. This slide is kind of a little bit more of what we do in watershed forestry. We have a bridge cost share program. Some of the pictures that you see on the slide, I'm going to go to my laser pointer. These are wooden bridges that we had built and actually gave away to logging contractors who were eligible for those bridges. They were made in East Montpelier. This is 5 steel bridges that we had constructed and did a cost share with eligible logging contractors. And those bridges are owned by the contractors after we do the cost share and the giveaway, obviously. But we do also have a rental program where this bridge here is a 25-foot steel bridge that's used as can be used as a skidder bridge, and if the distance is shortened up, can be used as a truck bridge as well. And we have 3 of those bridges, and we have 2 heavy-duty 100,000-pound rated bridges like this one here, which is a 40-foot bridge that's going in down in Stockbridge. This was maybe a year ago, and then so we get a lot of bridges out there. I think we've almost 80 bridges in the last 3 years. We've gotten out to logging contractors for implementation of good water quality practices. We also do education and outreach. We do lots of logging contractor and forester workshops. This picture here is just the other day, actually, in Boyer State Forest. We had a LEAP. LEAP is the Logger Education to Advance Professionalism, and they have a core curriculum of courses that we present. Forest ecosystem management. We have a professionalism course that LEAP does, and the watershed foresters and the AMP foresters help with that program as well. That's Rick Dyer, who was an AMP forester who worked with that workshop. These are other trainings and essentially get-togethers where we this photo here is all state foresters, learning from Pat Ross, the river management engineer, about permanent and temporary crossings relative to the new AMP manual that was out in 2018. And then we also work, which is most of my discussion today, is going to be how we help agency lands with technical assistance on improving infrastructure and following good water quality practices. So that's a little bit about what the watershed forestry program is. Now, in Vermont, A&R lands make up a pretty good chunk of land. We have 360,000 acres. 8% of Vermont's forest land is made up of A&R lands. And if you look at the numbers, 39 state forests, 55 state parks, and 80 WMAs make up the majority of that land. But also we have several DEC dam sites, fish and wildlife pond sites, and many fishing access areas that Fish and Wildlife owns and manages. And on those lands, we have approximately 600 miles of roads and 1,500 miles of trails. And well, we all know forest land protects water quality more than any other land use. It's very important that the work that gets done on those lands gets done in a manner that protects water quality. And when we manage forests and we have recreation trails and all of the access that happens on state land more and more access is happening on state land. We need to ensure that we protect water quality while we do that. Relative to the TMDL, forest land is estimated to contribute approximately 16% of total phosphorus loading to Lake Champlain, primarily coming from the runoff from roads and trails, where we have modified the landscape. And FPR and Fish and Wildlife and DEC has for decades managed our roads and access points on state land. A lot of the access is for timber management, and we regularly we get a minimal, I would say, state forest highway budget to manage those roads for access, and periodically we would get some increased funding through the ERP ecosystem restoration program to address erosion issues and sedimentation on state lands. Those are projects that are specifically designed to reduce erosion and prevent sedimentation. And it was a project by project basis. The applications were time consuming because there were lots of details needed to meet the program requirements. And it was becoming a time sink to do all that and to do it well. And essentially, with discussions from DEC and trying to come up with a better way to implement those clean water funds, in March of 2020, right before COVID sent us all home, FPR met to begin discussions to create a comprehensive method for assessing roads, determining needs, and prioritizing projects. Again, this was related specifically to erosion and sedimentation in order to reduce the amount of phosphorus reaching Lake Champlain specifically, but clean water projects are important everywhere. So we met in March, mostly stewardship foresters, state lands foresters, the A&P foresters, and we decided to model our system after the Municipal Road General Permit, MRGP process, which many folks know is the way that towns are managing their roads, and it's a good system, and we wanted to adopt it. The one big difference is we were going to use the acceptable management practices instead of what the MRGP practices were using, and the MRGP requirements process, I should say, is essentially it's a map with hydrologically connected segments. It's a Survey 123 app, and then a series of questions that helps prioritize the need. And it is all based on hydrologically connected segments. It's not a structure by structure inventory. It's a 100-meter segment inventory of those segments that are hydrologically connected. And again, we use the A&R road erosion inventory. Standards are the Vermont Water Quality AMPs, and the MRGP uses the Vermont Better Roads Manual for town roads. Again, the roads are different in amount of use and size and so on. What are the AMPs? Basically, the AMPs have been around since 1987 to help assure that forest harvesting met clean water standards, and they are basically 26 practices to protect water quality, prevent soil erosion, minimize stream impacts, and protect water quality on all aspects of the job: truck roads, skid trails, stream crossings, forest buffers, log landings, applied before, during, and after the harvesting, and also in between the harvesting. So harvest may take a year, may take 2 years, and then there's 15 or 20 years in between the next harvesting phase. And while the land is sitting idle, growing trees, those AMPs need to be in place to protect that infrastructure, so it's not washing out, so it's not adding sediment to waters, and many of those trails get used in between. So the AMPs are also have standards in many of the tables. Table 1 is about water bar distances and ditch relief culvert distances that help maintain or help spread out the water. And then we have recommended sizes for stream crossings, both temporary and permanent on intermittent streams, and temporary crossings on perennial streams. The principles of clean water on forest roads is again the same as the principles pretty much everywhere. You know, we want to disconnect stormwater from streams whenever possible, and have a perpendicular flow of water across the road, not down the road or even down the ditch for very long. We want to infiltrate stormwater. We want to slow it down, spread it out, stabilize conveyances, turn out ditches, and basically spread the water back out. And you can see in the photos similar, very, you know, this is a new cross drain culvert with stone line ditching, stabilizing that structure. This is a stone check dam, and this photo, I have my little thing is in the way here. Properly sized culverts, which is another huge aspect of clean water principles. You have to have the right size stream crossings, or with the streams with the storms that we're getting and the amount of flow, we're failing to protect water quality if we don't have the right stream crossings sizes. There we go. So one of the first things we had to do to create the road erosion inventory for state lands was to come up with road types, because different roads have different standards, and we needed to be clear that we defined those and made it clear exactly what type of road that we were inventorying and what standards we were applying. So we have 4 road types. The first type, type 1 road, is a road that is not a forest management road, so it does not have the AMPs as the standard. These are recreational and management access to Vermont state parks, ski areas, fish and wildlife access areas, etc. And they use the MRGP standards right out of the box. MRGP standards for roads with open drainages and either paved or graveled, but no catch basins or enclosed drainage. So type 2 roads, type 3 and type 4 roads use the AMP standards, and those are basically gravel surface roads. Type 2 roads are a little bit wider than type 3 roads, but very similar. Mostly type 2 roads get graded, whereas type 3 roads have water bars and broad-based dips that drain. That type 3 roads do not get graded typically, but they're both graveled surface roads. Type 4 roads are native material, generally utilized during frozen conditions as a winter harvest road, and also include designated VAST trails, Vermont Association of Snow Travelers, groomed snowmobile trails. A lot of these have crossings and ditches. They just don't have gravel, and they have water bars and broad-based dips that drain the surface. And so we talked about hydrologically connected road segments. So what is a hydrologically connected road? It's a segment of 100 meters that is within 100 feet of within 100 feet of a water resource. It bisects or drains to a water resource. or so it can run parallel to a stream, or it can cross a stream, essentially, or it is uphill and has a ditch that drains to a segment that bisects or is within 100 feet of a water resource. And these segments can be many segments away from a crossing, but up a hill, so that there might be 5 segments draining to that stream, and all 5 would be hydrologically connected until you get over the hill, and there's a some kind of a topography feature that drains the water in the other direction. And the connectivity status can be changed during the inventory. That's one of the first things that you do, is determine if that segment is in fact hydrologically connected, or you could take a segment that was not labeled hydrologically connected and make it hydrologically connected. And water resources include perennial streams, intermittent streams, even dry streams if they have a defined channel, which is a bedrock or gravelly channel with no leaves or grass. It does include open water wetlands and lakes and ponds. So here's a map of the Little River area of our road centerline data, and the purple segments are the hydrologically connected segments. So the ANR road erosion inventory, very similar to MRGP. The MRGP uses 2 programs to complete the survey. It uses what's called field maps. It used to be collector, but now it's field maps to manage the map and to manage the segment IDs and some of the background information that was entered into or calculated for each segment. And then once you select the segment, you open up Survey 123, and that's where the data gets collected for each segment. So this slide shows on the left, zoomed into in field maps, the segment. And you can see the little segment that's highlighted there. If you hit launch inventory, it would give you the next screen, and it would actually pre-populate all of these fields based on the information that's in the field map. So you don't have to enter all this over and over and over. And if you look at the third image, you see segment ID is already uploaded. The road name is uploaded, whether it's hydrologically connected or not is uploaded. And then the road type is uploaded. That's all from what our Brian Knox, our IT specialist, does in field maps with the road centerline data. And then the first question you have to answer when you're in the field is you verify if it's hydrologically connected, and then you would put in the field determined percent slope. And then you're off and running. And I'm not going to go over the whole survey, but I want to go over each, just the parts of the road that of the segment that we look at. So this slide shows the first image is the travel lane in the crown. And we look at, so that's basically the part of the road that you drive on, typically, basically. The next segment is the road shoulder and ditch area. So that's the part of the segment that is not the travel way, doesn't include cross drains or culverts. It's just basically, is the water shedding off of the segment in a distributed manner. The third image has to do with drainage culverts. So we look at the road drainage and if there are drainage culverts, and if there at any point in the segment there aren't drainage culverts, then you would hit either not applicable or no, and it would not flag that as a does not meet the standard sort of thing. So we look at, again, the travel lane, the road shoulder, and the drainage culverts. and then stream crossings and disconnection culverts, and then forest buffers. So there's 5 parts of the segment that we look at and answer questions related to each one. And again, if there aren't stream crossings, then there doesn't need to be disconnection culverts, and you would just answer no, and you wouldn't have to answer any other questions. So it's basically a very simple form that you go down through on your iPhone. These are all uploaded or apps available on your phone. You can put them on a tablet, but and they work very well. And I'll just really quickly talk about what a disconnection culvert is. Basically, if you have a ditch line running down a hill with a stream at the bottom of the hill, we don't want the ditch to discharge directly into the stream. So what you need is a turnout of that ditch, or a disconnection culvert, a ditch relief culvert that brings the water under the road and then turns the water out into the forest buffer on the downhill side of the road, at least 25 feet back, so that it has time to dissipate the sediment and energy before any of that sediment gets into the stream. That's what a disconnection culvert is. We also have practices that can be noted in each segment that are necessary to bring it up to the standards. So if the road segment requires maintenance, you would click yes, and you could enter any of these practices that are necessary to improve that segment. And this is really just it's essentially notes. It allows us to put into the program some ideas of what need to be done to bring it back. And then when we go to utilize the information to come up with a plan, this will help us determine what needs to be done. And 9 times out of 10, you're going to go out to the segments that need work, and you're going to again look at all of this and come up with a plan. But this is helpful information to have. So the goal of the road erosion inventory is to be able to prioritize those segments that need the most work based on if they don't meet the standard and related to the slope of the segment. So if you had a segment that has 10% slope versus a segment that has 2% slope, which is the one that is going to be a higher priority given the same amount of issues or whether or not they meet the standard. It's going to be the 10% slope segment. So this slide shows the different scoring scenarios for the travel lane and the shoulder, and so what it does is determines if that travel lane meets the standard or partially meets the standard or does not meet the standard. So this slide shows the travel lane and the shoulder. This slide shows the drainage culvert, stream crossings, and forest buffer scoring. And we don't need to go through all of these. Essentially, if the culvert, it goes mostly in the biggest factor is there erosion? Is there none to rill erosion? I'm sorry, none to rill or gully erosion, or none to or sheet flow. So if the culvert, if a practice is missing but there's no erosion, it meets the standard. If the practice is missing and there's rill erosion, it partially meets. If the practice is missing and there's gully erosion, it doesn't meet. So that's a rough description of what the scoring does. So the overall scoring, because there's 5 different segments, you could have 4 fully meets and 1 does not meet. I'm sorry, there's 5 different parts of the segment, each with its own score. But what is the score for the entire segment? And that's what the overall segment scoring tells us. To fully meet the standard, all scores must be fully meets. For partially meets, 1 or 2 individual partially meets, or does not meet, essentially any does not meet score or 3 or more partially meet scores creates a final score for that segment that does not meet the standard. And then we apply that to the different slopes, and then we have the priority here with from low priority to highest priority. And when in survey 1, 2, 3, when the surveys are all done, it will tell us the priorities of each segment based on all of these categories. And the phosphorus accounting, which is very important for the TMDL and how we're doing and how we can impact the reduction in phosphorus. If you, after you do an inventory and you determine that you have a series of segments that do not meet the standard, and you go back and do work that improves them so that they do meet the standard, it can change the phosphorus loading rate or reduce the phosphorus loading rate by 40% for moving a does not meet to partially meets, or changing it from does not meet to fully meets is an 80% load reduction. So that's where we account for the phosphorus in this process. And again, if the segment does not meet, then there's 0 reduction until it is either brought up to the standard of partially meets or fully meets. So talking about implementation, over the summer of 2020, I worked with Jim Ryan and Ryan Knox to develop the REI methodology, and in the winter of 2021, FPR started putting together the centerline data and classifying the roads. And last spring, we started on the ground with the REI, assessed several projects that had obvious erosion identified by the district stewardship teams. We did not have a complete survey of everything. That's going to take some time, and we do have a contractor who is going to start this spring doing 1/3 of the roads, roughly 1/3 of the roads, and then in the future we'll have that for the prioritization. I think I have a slide that discusses that a little further on. And over the course of the 2021 field season, last field season, FPR completed 7 projects totaling over $488,000. And I wanted to just highlight one project that we did on the Cotton Brook Road. A lot of folks know where the Cotton Brook Road is because it's a very well-known and well-used recreation place from biking to snowmobiling to hiking, cross-country skiing. It's in Moscow, which is part of Stowe. It's a very important resource for lots of folks. It was built as a forest management road. We haul logs on it periodically, and it had when we did the REI, we had many segments that needed improvements to bring the standards up for truck roads. This was a type 2 road, so it was a wider road. It was big enough to be graded, but the gravel, the surface material, was not really acceptable for grading, so we improved that as part of the project. A lot of the things that we did: ditch relief culverts, disconnection culverts, armoring, and then properly sizing structures, recrowning, and then installing new road surface material, which again allows us for better maintenance, and it's a much more durable surface for the flow. A lot of the material that was used on that road over in the many years for many years was bank run gravel that we found or in a couple different locations along the road, and it was very sandy. It was good to have, but not the best material that we could use. So a lot of ditch relief and disconnection. There were nowhere near enough ditch relief culverts based on the slopes. There were very few disconnection culverts where the ditch on the right in this photo used to go all the way down and into this. There's a stream down here. You can see that stream wasn't necessarily impacted with the work, but we just put a new ditch drain culvert in there, and then so it essentially shortened this ditch that went into that stream. Again, a lot of turnouts. In some places, the road was a dugway, didn't have a lot of positive drainage on either side, so we added these turnouts here to get even the high side of the road to flow off the road, and a lot of culverts needed to be upsized, essentially. For years, culverts were put in based on how much water they saw in August when they were out there doing the work, because that's the dry season to get the work done. And really, you need to go look at the stream in late March, early April to figure out what size your culverts need to be. And now we have the A&P manual, which gives us culvert sizing by drainage area, which is a much better way to do it, and active channel. Here's some before and after pictures of one of the crossings. Here's another crossing that not only is the culvert too small, but it was perched and it had been eroding the stream, the road edge. This is a very steep stream. It's an intermittent stream, and you can see an old piece of culvert down there. It's probably the previous culvert, which was a lot smaller, and but still they needed to do a much bigger culvert, armor the bank, and prevent that sedimentation from going down into, well, this is a stream here, but eventually ended up in the Cotton Brook. And then a lot of road surface and shoulder improvements, putting in a material that could be graded and that has a positive drainage that sheds that water off the road, doesn't allow it to go right straight down the road. And you can see here a nice crown and cross drainage culverts installed. And a lot of ditches, or I'm sorry, shoulders were regraded to establish positive drainage so that the water didn't just, when it got off the road, didn't run down the margin of the road and the shoulder and create a false ditch, which often happens. And that turns into, you know, rill erosion and gully erosion very quickly. Getting that road shoulder to accept the water in a distributed manner. And then a new wear surface, which is expensive, but really goes a long way to allowing for better maintenance and also just being a better wear surface and not allowing the water to create those rills and gullies. So here's the project summary. About a mile of road was resurfaced, and this is only hydrologically connected segments. Basically, not a lot of water bars because we put in a better surface so we could crown the road, but 33 cross drain culverts needed, and all of those had end treatments completed for the culverts. They weren't just culverts put in without any headers or footers. A little bit of stone line ditch, 80 feet, which relative to town roads isn't that much, but unlike town roads, we can throw in a cross drain culvert pretty much whenever we want because we own the land on both sides of the road. We don't have to worry about putting all the water across Mrs. Smith's, raspberry bushes, which makes a big difference. And we do that. One of the biggest things that we do is add cross drain culverts, and 10 stream crossings improved. All of those were intermittent streams, but that in itself is a huge project and undertaking to do that many stream crossings. So the next steps, I talked a little bit about this, but we have a contractor slated to start the inventory process of the first third of our forest road miles on agency lands this spring. And we're working on mapping and segmenting and getting the rest, the remaining 2/3 of the roads ready for another contract later in the spring, maybe early summer. And we have another 13 projects that have been identified by the stewardship teams to be implemented during this coming field season. And then once that's done, then the next round of implementation projects will be coming right from the REI process. The prioritization and project identification will come right from the REI. And I just wanted to send say thanks, a special thanks to Jim Ryan, who we couldn't have done this without Jim. He is the MRGP specialist, and he really went out of his way to help us create the REI. And Ryan Knox from ANRIT was instrumental in helping us put this together. And Pat Ross, the river management engineer, with the AMPs and all of the work that we've done trying to improve the AMPs, Pat has been very helpful. And then obviously, I don't go out and implement all those projects, but the state land foresters do that, and they do a great job. And obviously wouldn't happen without them. So that is what I have. I'm gonna unshare. Whoops, that's not right. How do I do that? Or did I do that? Am I still sharing, Mary?
No, you're not.
Okay, good. A couple minutes left, not 15, but.
No worries. Thanks. That was great. Sorry, my mute button was challenging me. We have a couple questions, which hopefully we'll have time for them. I also want to say we have a feedback survey that's going to be posted in the chat. If you would please it's very short and easy, quick. So if you would please take the time to fill that out, it's really helpful. Our first question from Gianna is about, do segments ever get broken into smaller chunks if hydrological connection varies? For example, if 100 feet goes up and over a hill, would that break up for any reason?
No, we don't break up the segments that way because they get created in GIS before we get out there on the ground, and having that level of detail, we just don't have. And then the segment is the segment. So we essentially score the part of the segment that flows towards the hydrologically impacted stream. The rest would not be. We wouldn't score the rest.
We have another question from Eric Brown, which is, do used plastic culverts get recycled? And if so, where?
I don't think they do. I would love to know if they are able to be recycled. The used metal culverts definitely get recycled, especially right now with scrap prices as high as they are. All you got to do is say, hey, will you take this culvert away? And the contractors will just do it because they can, that they can collect from that. But plastic culverts, I do not know. But if anybody does know, I would love to find out. And from my recollection or from my experience, plastic culverts do not get recycled. So, and there's there's a couple different kinds of culverts. There's gray culverts and black culverts. But I don't know that answer.
Yeah, I think there's some challenge with recycling like black plastics.
Mhm.
A lot of black plastic culverts I see are black. Well, it is 12:46, so thank you very much for giving your presentation and for everyone for attending. If everyone would fill out the feedback form, that would be wonderful, and you can stay in touch with us through our listserv. Thanks everyone for coming.
Great
Thank you.
presentation, Dave. Thank you.
Thanks.
Have a nice weekend.
All right, you too.
Yep, thank you. That was good.